Alright, so let's start by looking at 8.2 transformations of logs. Before we do that, it's really important that we remember a few things about logs. First of all, logs are inverse of exponential function. That's very important. That means they're reflected over that special line y equals x. So all logs and exponentials are reflections diagonally of each other. Remember that if you have an exponential function, y equals c to the power of x, then to find the log function, you have to start by switching the x and y. So notice that the x and the y are switched from the exponential to the log before you change it into logarithmic form. So again, be very careful to calculate an inverse. The x and y have to switch before you change the form to a log.
So it has to be x equals.
So this one says determine the inverse of y equals 4 to the power of x. So to determine the inverse, my first step is I have to switch the x and the y. So I'd say that x equals 4 to the power of y. Then you change it to log form to get the y by itself. So this would be that y equals log x with a base of 4. So that would be the inverse equation of y equals 4 to the power of x. Again, switch x and y, and then get y by itself. Now here it says, solve the inverse if x equals 16. So if x equals 16, we'd get y equals log 16 with a base of 4. So in your head, you should be thinking, okay, 4 to what power gives me 16? 2, right? So this would be that y equals 2. Remember, we also have a fancy little change of base formula that we did before that said you could take log of 16 and divide it by log of 4, and that would give you your answer as well. And that's where it uses base 10 automatically in your calculator to come up with your answer. Alright, so when we're graphing this function, we need to always start by thinking, okay, what's my a, my b, my h, and my k? Now remember that function transformation notation was a, f, b, x minus h plus k. But if I replace the f with now a log function, because remember the f here means any function. So if I replace that with the log function, what we're looking at is a log, and I'll have a certain base onto it, so I'm going to call that little base c, b, x minus h, and then plus k. So remember that the b and the h are in with the x, which means they're in with the log function. The a and the k are stretching your y values, so they're not applied into the log function. So in this example, we have a base of 3, an h value of minus 9, be careful with your signs, and a k value of positive 2. So I know that the function I'm starting with is going to move 9 units to the left and 2 units up. Now, in order for us to do that, we need to figure out what our base function is. So remember that in this case, our base function would be log x with a base of 3. So if there was no h and no k, we'd only be left with our base function. Now we need to first of all draw this base function. So now when I make this into a table of values, I'm going to plug in y values because in an inverse function, I'm trying to look at what my x's are. So this time I'm going to plug in -2, -1, 0, 1, and 2 for y. Again, an inverse function, your x's and your y's are switched. So your table of values appears switched as well. So this would be 3 to the power of -2, which is 1/9. Then 3 to the power of -1, which is 1/3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. And 3 squared is 9. So I have my table of values, but I had to start with y's and find x's. Then we're going to plot this on the graph. So your original graph should look something like this. Now the easiest way to do this question is just to move your graph. You could use mapping, okay, but there's no need to do mapping when you just have h and k, because all I have to do to this graph is move it 9 units left and 2 units up. Now that includes my vertical asymptote, because remember there would be a vertical asymptote at 0. So now where's that vertical asymptote going to be? At -9. It's going to move 9 units to the left as well. Okay, now with this new graph, once we moved it left 9 and up 2, we have to find all of our new information. So the asymptote is a vertical asymptote and moved over to -9. So now we have x equals -9 is going to be the equation of our vertical asymptote. The domain here has also moved because my vertical asymptote is moved. So my domain is that all my x's are going to be greater than -9. Again, they're all to the right of -9. The range will still be an element of reals because the graph is still going up forever and down forever as we plug in different x values. Now here's where this gets tricky. The y-intercept and the x-intercept. It's not clear on this graph where my y-intercept is, but how can you always find a y-intercept? Plug in 0 for x, right? So to find a y-intercept, as always, we're going to set the x equal to 0. So in this case, we have y equals log of x plus 9 with a base 3, and then the k value is 2. So here again, I'm going to put a 0 in for the x. That means I end up with log 9 with a base 3, and then plus 2. You have to calculate the log part first, because the k value is separate from it. So what you should think in your head here is, okay, 3 to what power gives me 9? 2, yes, 2. 3 to the power of 2 gives me 9, which means if I evaluate log 9 with a base 3, I get 2. And then, when I add the 2 at the back, we get 4. So y equals 4. Okay, so for the x-intercept, we're going to start by plugging in y to 0. So when I put a 0 in for my y, I have to try to get the log part by itself. So I'm going to start by subtracting that 2 to the other side. Now from here, I can't really evaluate this in log form, so I would change it to exponential form. So our rule says that my base is 3, my exponent is -2, and then the thing in the x spot here is x plus 9. So that's where that came from. Now, 3 to the power of -2, you could calculate that on your calculator if you wanted to. You'd get a small decimal number. Or you could think, okay, 3 to the power of -2 is like 1 over 3 squared, which becomes 1 over 9. So we have 1 over 9 equals then x plus 9, and then I need to move this 9 to the other side. So when you have 1/9 and you subtract 9, you get approximately -8.89. Which, if you look at your graph, it would be approximately there at -8.89, because it's going to be really close to -9, but not quite touching it. And your y-intercept as well as should make sense that it's at 4. So those would be your x and your y-intercepts. So here we're going to use transformations to sketch the graph of y equals negative log of 2x plus 6 with a base of 2. Now I need you guys to be very careful. Remember that our equation is a log b x minus h plus k, but notice that there's that set of brackets around the x minus h. We do not have another set of brackets within my b and my h here, so I need to factor the 2 out to be in the b spot, and then that'll affect my h. So we have done this before in chapter 1, and I'm just reminding you of that here. So I have an a value that's a -1. My base is 2. Now if I factor out the 2 from the 6, I'm left with x plus 3. So you have to factor that b value out because it changes your h. So now if I look here, I have an a that's a -1, a c or a base that's 2, a b value that's 2, and an h value that's -3. So there's a lot going on in this transformation, and it'll be best to use mapping. So we're going to start with our base function here, and remember to come up with the table of values for your base function. We have to plug in some y values, and we'll get our x values. So the y values I'll use are -2, -1, 0, 1, and 2. Then we get 2 to the power of -2 is going to be 1/4, 2 to the power of -1 is going to be 1/2, 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So remember that your table of values is switched because your x's and y's are switched in inverse functions. Now on this one, we're not going to graph our original because we have so much other stuff going on. Instead, we're going to map this one. So we're going to use our mapping equation. Okay, so with our mapping notation then, we are going to take, let's take our first point. It's 1/2 and -1. And when I plug that in, we're going to get 1/2 divided by 2, subtract 3, and then -1 times -1. Now you can use your calculator for this, but 1/2 divided by 2 is going to be 0.25, and then we subtract 3, so we get -2.75, and then the -1 and the -1 is going to be a +1. So my 1/2 and -1 is going to now be at -2.75 and 1. Then let's take our next point, which is a much nicer one. It's 1 and 0. I'm going to get 1 divided by 2, subtract 3, and then -1 times 0, which is going to be -2.5 and 0. Let's then do the rest of our mapping points. So again, then we should have all of our mapped points. Remember that your vertical asymptote is also going to move according to our h value. So my h value is -3, which means my vertical asymptote would be moved over 3 to the left. So my new vertical asymptote is going to be over here. And then we can plot our other points. So my first point was -2.75 and 1. Then I have a point at -2.5 and 0. And then I have a point at -2 and -1. And a point at -1 and -2. So you can see that your graph is kind of curving down this way. It should make sense that it's flipped because your a value is negative. So you should be able to check that your graph has been flipped, made half as wide, moved 3 units to the left. So to finish this question off, we can take a look at domain. I see my vertical asymptote has been moved over to -3, which means my domain moved along with it. So the x's are all going to be greater than -3. The ranges are still an element of reals because even though this graph was flipped, it's going up forever and down forever. Now my x-intercept, I actually have it. One of my mapping points landed nicely on the x-intercept value, so I know that my x-intercept is at -2.5 and 0. My y-intercept did not hit nicely, but remember that we can always find a y-intercept by plugging in x to 0. So when we plug in the 0 for my x, we end up with log 6 base 2 and that negative out in front. Now we have to calculate the log 6 with the base 2 first, and you can use your change of base formula to do that. So you'd go log 6 divided by log 2, and then apply the negative. So it's actually going to be negative, and then 2.58, and then when you actually multiply the negative into the 2.58, you get a y-intercept of -2.58. So when I look back to my graph, the y-intercept should be approximately -2.58 with an x value of 0. And our final example for today, we have shifted the blue graph to now be the red graph. So my point was going from 4 and 1 to now being at 1 and 1. So I can see here that it's my x-axis that's changed, and I see that it's been squished from 4 to 1. So I know that I've got here a b value, and I need to figure out what that b value is. So again, if my graph is shrinking, it's getting narrower, that would mean b equals 4. So we have 4 in the b spot. Again, because to go from 4 to 1, I've divided by 4, and your b seems backwards, which would give me a b value of 4. The final thing to talk about today is this idea of e. So we often see, instead of having log x, we'll sometimes see a base of e. So we'd say that it's log x with a base e, and that's actually written as ln x. Ln x is a button on your calculator. Again, it just has e for a base, and e is actually equal to this number if you also check that on your calculator. So please complete these textbook questions for tomorrow, and we will have a look in class. Thanks. Have a good night.